Circle geometry here, and they give us this picture here, and they tell us a few things. They tell us that this is a tangent. Should read all of this stuff very carefully, and they tell us that R1 is 50 degrees, and then these points on the outside of the circle, but you should read it all very carefully. Determine the size of R2 with a reason. Well, you know that R2 has got to be 90 degrees, but why? Well, this tangent is perpendicular to the radius, or perpendicular to the diameter. This is the diameter it's given. So that's why this is 90 degrees. That's why R2 is 40. Why is WSR, why is this angle 50 degrees here? Well, the reason it's 50 degrees is you could do it too. The first time I looked at it, I went, oh, that's 90. If that's 40, that's got to be 50. So angles on a semicircle kind of give it to you, but I think this is a little better. The tan chord theorem gives it to you right away because if that's 50 degrees, the angle between the tangent and the chord, then this is directly 50 degrees WSR. So I like the second one better, maybe. The last question, prove that WVPT is a cyclic quad. Well, how could we do that? Well, we know that W is 40 degrees because the angles summing in this triangle, there's 90, 50. We know W is 50 degrees. We know that P1 must be 40 degrees because of angles in the same segment. See how P1 and R2, which are both 40, open up to the segment TS? They've got to be the same. And then I think we have it. Look at that. Here's the cyclic quadrilateral we're trying to prove, WVPT. There's an exterior angle, and it equals the opposite interior angle in there. So WVPT is a cyclic quad, and the reason is the converse of the exterior angle of a cyclic quad. And that's it.